In this video, I'm going to explain how metals are extracted, especially for the medium reactivity. The first step is what? Concentration of ore. Okay, concentration of means removal of impurities such as soil, sand, stone, silicates, okay, etc. from the mines ore is known as concentration of ore. The ores which are mined often contains many impurities. These impurities are called gangue. Okay, first of all, the concentration is done to remove the impurities from the ore. The concentration of ore is also known as enrichment of ore. Okay, the process of concentration depend upon the physical and chemical properties of ore certain. Okay, there are some methods like the gravity separation, the electromagnetic separation, cross flotation method which is used for sulfide ores. Okay, are some examples of process which are applied for concentration of ore. Okay. After the concentration of ore, we are using the conversion of concentrated ore into crude metal. Conversion of concentrated ore into crude metal. See, conversion of metal oxides, okay, metal ores into oxides. It is easy to obtain metals from their oxides. Okay, generally, so of ores found in the form of sulfide and carbonates are first converted into their oxides by the process of roasting and calcination. Okay, so oxides of metal so obtained are converted into metal by the process of reduction. So what is roasting and what is calcination? I have explained in one with you, children. But also you can watch. Here, roasting is generally used for sulfide ores. In this case, the sulfide ores are heated strongly in the presence of air. It gives you metal oxide. For example, zinc sulfide react with oxygen. Okay, are heated with oxygen, give you zinc oxide plus sulfur dioxide. Similarly, calcination it is used for carbonate ores, children. Okay, in this case, carbonate ores are heated strongly in the absence of air or oxygen. So you can see zinc carbonate upon heating it gives you zinc oxide plus carbon dioxide. So this is the second step we are getting conversion of concentrated ore into crude metal. So here there is a difference table you can learn. This is very important. See, after that the metal oxide we have to do the reduction. Okay, reduction of metal oxide into metal. The third step is what? Reduction. Heating of oxide of metal to turn them into metal is known as reduction. So we are using with the help of reducing agent. Okay, auto reduction is also there, children. Let's talk about this extraction of metal of least reactivity. So mercury and copper, which belong to the least reactivity series, are often found in the form of their sulfide ores, like cinnabar, HGS, ore of mercury. This is the ore of mercury. Copper glands, Cg2s, it is the ore of copper. Extraction of mercury metal. How we are doing that? So cinnabar is a first heated in the air because it is sulfide ore, so we will do roasting. So this terms the HGS, that is mercuric sulfide in, or cinnabar into HGO, that is mercuric oxide, by the liberation of sulfur dioxide also. Okay, so mercury oxide is obtained, okay, again by heating strongly. Okay, this reduces mercury. Okay, you can see the equation. What happens? HGS, that is the ore of mercury is there. It is heated strongly in the presence of air. Okay, it gives you HGO. Again, if you heat this mercuric oxide HGO, you will get the pure mercury. Is it clear, student? Next, extraction of copper metal. How is the extraction of copper metal? We'll see. Okay, so copper glands. Okay, that is what Cu2s is roasted in the presence of air. How we are using roasting? Because it is a sulfide ore. Yes or no? The roasting turns the copper glands into copper oxide. The copper oxide is then heated in the absence of air. This reduces copper oxide into copper metal. I see here copper glands Cu2s react with the O2. It gives you water Cu plus SO2. Balancing you can do, children, 2Cu2s plus DO2 gives rise to 6Cu plus SO2. Now what happens? That is here Cu2O will come to that. Okay, copper oxide. Copper sulfide change into copper oxide. CuO children. So this Cu2O. Now this Cu2O is again heated with the ore itself. Okay, here copper oxide this one, copper sulfide this one. Children. Okay, here mistake is there. Cu2S is copper sulfide, Cu2O is copper oxide. What happens then? This is here Cu2O. Okay, Cu2O. Copper oxide is here. Okay, Cu2O formula you see. So Cu2O, that is copper oxide, react with the ore itself. It gives you copper plus sulfur dioxide. In this way, coppers are also extracted. Next, extraction of metals of medium reactivity, like zinc. You can see here iron, okay, zinc, lead, etc. are found in the form of carbonates or sulfide ores. So carbonate or sulfide of metals are first converted into their respective oxides. Okay, and then oxides are reduced to the respective metals. Next, talk about the extraction of zinc, children. The zinc blend, ZNS, zinc sulfide and smithsonite or zinc spar or calamine. Calamine is very important. ZnCO3, zinc carbonate are the ores of zinc. The zinc blend is roasted to be converted into zinc oxide. Okay, and next zinc spar is put under the calcination to be converted into zinc oxide. So here you can see, children, zinc oxide react with oxygen, gives you what? Zinc oxide. Zinc sulfide react with oxygen, gives you zinc oxide plus sulfur dioxide. Why we are using the what is this? This is the roasting actually. If it is a sulfide ore, we are doing roasting, hitting in the presence of oxygen, gives you zinc oxide. And if it is a carbonate ore, so we are hitting strongly in the absence of air. So we are using calcination. So we will get a ZNO plus CO2. Is it clear? Zinc oxide is obtained, okay, in both the cases. For sulfide ores by roasting, for carbonate ore by calcination. So what we are going to do, we are going to use the reducing agent written. So coke is or carbon is the reducing agent. The zinc oxide so often is reduced to zinc metal by heating with the carbon. Okay, a reducing agent. Zinc oxide reacts with coke, gives you zinc plus carbon monoxide. In this way, zinc oxide is reduced to zinc. I hope you understood these concepts. Okay, so next let's talk about the extraction of iron. Okay, how it is extracted. Hematite ore is heated with a carbon to be reduced into metal. So Fe2O3 react with a carbon, gives you what? Fe plus PCO2. Yes or no? And now next extraction of lead from the lead oxide. Lead oxide is heated with the carbon to reduce the two metal of lead metal. So PbO reacted with coke, gives you what? Pb plus CO2. Is it clear? Okay, reduction of metal oxide by heating with aluminum. This is also there. This is also. These are the method of what? Reduction of metal oxide into metal. Here PbO to Pb, Fe2O3 to Fe. Similarly, MnO2 to Mn. So here we are using a thermite process. So metal oxides are heated with aluminum, a reducing agent to be reduced to metal. Following is the example. So manganese dioxide and copper oxides are reduced to respective metal when heated with aluminum. So MnO2 you see react with the Al, give you what? Mn plus Al2O3. So magnesium dioxide react with aluminum, gives you manganese plus aluminum oxide. Similarly, copper oxide CuO react with aluminum, which leads to copper plus aluminum oxide plus heat. So CuO is reduced to copper Cu. So, thermic reaction pattern. So what is thermic reaction? Very important. The ferric oxide, when heated with aluminum, is reduced to metal, okay, iron metal. Yes or no? In this reaction, a lot of heat is produced. The thermite reaction is used in welding of electric conductors, okay, iron joints, etc. Okay, it has joints in railway track. This is known as the thermite welding. Okay, TW. What happens then? Fe2O3, that is the rust react with aluminum powder, gives you what? 2Fe in the liquid state. That's Al2O3. Okay, plus hydrogen. Plus heat actually, it is for heat. Okay, yes or no? Next, this reaction was discovered by thermometer. That's why it is called a thermite reaction. Okay. This reaction is also used in welding. Okay, of the railway tracks, railway tracks. See what happens? The rust is here now. After this reaction, we are getting molten iron. So that will occupy the gaps, and all cracks. Yes or no? Next, extraction of metal of high reactivity. Metals of high reactivity such as sodium, calcium, magnesium, aluminum are extracted from their ore by electrolytic reduction. These metals cannot be reduced using carbon because carbon is less reactive than them. Okay, so that is the reason. So we can see here then electrolytic reduction we are calling. Electric current is passed through the molten state of metal ores actually. The metal being positively charged is deposited over the cathode. Example, when electric current is passed through the molten state solution of sodium chloride, sodium metal gets deposited over the cathode. So what happens? Na plus within the electron become Na. This reduction at the cathode and 2Cl minus, and so those electron become Cl2 there. So overall we can write 2NaCl sodium chloride gives rise to 2Na sodium plus Cl2 chlorine. The metals obtained from the process of electrolytic reductions are pure in the form. Okay. And the last step we are following is what? The refining of metals or purification of metals. Okay. So metals extracted from the various methods contain some impurities. Thus, they are required to be refined. So most of the metals are refined by using electrolytic refining. Okay, we are using electrolytic refining filter. Okay, so electrolytic refining is easy only. Okay, here we are using the cathode. Okay, a strip of impure metal, an anode. It is a strip of pure metal. What happens? Cathode, at cathode, say suppose this is copper. Okay, and this is, sorry, cathode is what? Connected to the negative charge. This is what? A thin strip of pure metal. That is cathode. Anode is what? It is a thicker strip of impure metal. So the anode oxidation takes place. So copper will lose the 2 electron, become copper ion. And at cathode, reduction will happen. So Cu2 plus ion will gain the 2 electron, become copper. So it will deposit here. Here we are using the copper sulfate solution as the electrolyte, and impurities are collected at the bottom, that is as a anode mode. Electrolytic refining, you can see here, in the process of electrolytic refining, a lump of impure metal and a thin strip of pure metals are dipped in the salt solution of metal to be refined. So when an electric current is passed through the solution, pure metal is deposited over a thin strip of pure metal. Okay, from the lump of impure metal. Okay, yes or no? So in this, impure metal is used as anode and pure metal is used as cathode. Okay. You can see the reactions are there. Okay. So at anode, reduction will happen. Copper will lose the 2 electron, becomes Cu2 plus ion, and at the anode, Cu2 plus ion. Sorry, at anode oxidation means copper will lose 2 electron, becomes Cu2 plus ion. And at cathode reduction, so Cu2 plus ion will gain the 2 electron, becomes copper. Okay, so in this way, we can learn the extraction of metal. I hope you understood this concept, children. Please share with your friends and subscribe the channel.